This is the first video for the last section of Unit 2 in our notes, which is exponential models. So exponential models will be application problems and word problems. We will start with interest, investments, and business applications. And in our packet, we have the formulas for compounding and continuous compounding. And you can find them at the bottom of the first page from college algebra, but also at the middle of the second page for pre-calculus. So you have the formulas in a couple of places in your packet. The compounding interest formula says that the money accrued let's say funds at time t, which actually will be years. So t is the time in years. Will equal to P times 1 plus R divided by N raised to the quantity NT. P is the starting amount of the investment called the principal. R is the annual interest rate written as a decimal. It's the annual interest rate. And N is the number of compounding periods. So in your packet, these are not stated. You have to remember when you read the formula and understand what these mean. Now, what is compounding interest? Compounding interest means that your interest is received at the end of some period, not necessarily once a year, but it could be more often. And then it gets added to your principal so that in the next compounding period, you get interest on the added principal. And then the new interest, which in an additional quantity that you have accrued so far, gets added at the end of the next period to the quantity that gets the interest, and that keeps compounding. Now, quarterly means that you have 4 compounding periods every year. Monthly means that you will have 12 compounding periods every year. Suppose that the principal is $1,000. The interest rate is 8%, so as a decimal, 0.08. It's compounded quarterly, so your N is equal to 4. How much is in the account at the end of 3 years? And your T is equal to 3. So they are asking you to find A of 3, and that will be 1,000. 1 plus 0.08 divided by 4 to the 4 times 3. So in my calculator, 1,000 parentheses 1 plus 0.08 divided by 4, close the parentheses, to the 4 times 3 is 12. So the answer will be, because these are money, I will round to the nearest penny, 1,268.24. What if I have the same situation, same principal, same annual interest, but it's compounded daily? Daily will be 360. 365. And I know that we may have a leap year, but 365 is the most common. Therefore, they are asking me again at the end of 3 years, so the time is still 3. So I will have 1,000, 1 plus 0.08 divided by 365 to the, and here it will be 3 years times 365. So I'm going to do the same thing in my calculator. So 1,000 times 1 plus 0.08 divided by 365 to the, and here I'm going to open parentheses, NT will be 365 times 3. And it is now 1,271 and 22 cents. $1,271 and 22 cents. So the more often you compound, the more money accrues in the investment. A continuous interest formula has a compounding that happens every split second continuously, and the formula is principal times E to the RT. P is the principal, your original amount. E is the natural base, which is available in your calculator. R is the annual interest rate. As a decimal. And T is the number of years. So if I have an account of 2,500 that pays 4%, what will the balance be after 4 years if it has continuous interest? That's the key word here. So I'm going to apply the formula, 2,500 E to the 0.04 times 4. So in my calculator, 2,500 E to the 0.04 times 4. The answer will be 2,933 and 78 cents. If I invest 4,000 with 6% continuous interest, how long will it take for the balance to reach 6,000? So this is an example of a question where they are asking me for T. T is in the exponent. So the formula is A equals P times E to the RT. P is the 4,000, A is the 6,000, R is the 0.06, and T is the quantity that I need to find. So I'm trying to solve the equation for 1,000 equals 6,000 e to the 0.06 t. This is an exponential equation. I need to remember how to solve that. So first I'm going to divide by the constant that multiplies the exponential equation. My goal is to isolate the exponential equation. So I will get 46 equals e to the 0.06t. And then I'm going to take logs of both sides, or I will write it in logarithmic form. So let's take a ln of both sides. even though writing it in logarithmic form will imply a base of e. So I will get ln of 46 equals 0.06 t ln of e. ln of e is equal to 1 because I chose my base to be e. So therefore, to solve for t, I'm going to divide by 0.06. So I will get t equals ln of 46 divided by 0.06. This is the exact value. If they ask me to say round the number of years to the nearest tenth, I will have to evaluate this in my calculator. So I'm going to do a ln of 46. And some of you may have figured out that you could have simplified this to 2/3, which is fine. Divide by 0.06. And the answer is we have a mistake. And I see now where the mistake was. All right, I found a negative answer. And a negative answer is problematic because there is no way this happened in the past. In the future is when I'm expecting to see the increase. So where was my mistake? My mistake was that when I plugged in A, I plugged it in as 4,000 instead of 6,000. So I need to make this correction to make this A 6,000 and the principal a 4,000. And therefore, I'm going to be dividing by 4,000. And therefore, this will be 6/4 or 1.5. So not 4/6, but 1.5. Not 4/6, but 1.5. So let's try this again. The time will be a ln of 6/4, 1.5, divided by 0.06. Let's try this again. Now things make sense. So the answer is 6.75775180. Obviously, this is not an exact value, it's an approximation. If they ask me to round to the nearest tenth of a year, it will be approximately 6.8 years. How much must you invest today in an account that pays 5.5% continuous interest if you want to have $10,000 in the account 5 years from now? So that is again the A. The decimal value of the interest rate is 0.055. That's 5.5%. And the time is 5 years from now. They're asking me to find the principal. So again, I'm going to plug in the equation correctly this time to say 10,000 equals principal e to the 0.055 times 5. Now, e to the 0.055 times 5 is actually a constant. So to find p, I only have to divide by the number that multiplies p. The answer will be 10,000 divided by e to the 0.055 times 5. So that will be the answer in dollars. And again, I will round appropriately. So let's try that in our calculator. 10,000 divided by e to the 0.055 times 5. And the answer would be 7,595 and 72 cents. So 7,595 and 72 cents. So these are in dollars. Don't forget the units. when you are writing answers to applications. 75, 95, 72. And that's how we will do compounding interest problems.